What is it? Gina? Gravity.
How do you teach one of the most challenging primary science topics, mass, weight and gravity?
30.
Zoe Lowe, not a science specialist, agreed to let our cameras in. She's viewed the tape herself and now looks back at what went on with Science Inspector Steve Davis.
Right, need a bit more though.
Can I start with, at the very beginning, your learning objectives?
OK, books out. Date and objective, please, both underlined. You can write the keywords in a colour if you want to, if you've got one there. If not, don't worry. Something connected to what we're going to look at today, and we said that hopefully by the end of the lesson we'll understand the terms gravity, mass and weight. I'm hoping... It has to link back to, obviously, what has been built on before with the children and what they'd obviously learned either previously in the topic or last year. And I felt that the work they'd done on forces, it would be sort of an automatic step to go to here to then be able to move on. So definitely building upon what they'd previously learned.
There were some really interesting misconceptions to come out of it. There was this bit here where this boy who commented that he could jump higher on the moon and then you could stay there for a couple of minutes.
When you're on the moon, the gravity changes, so you just, when you jump, you just high and you just stay there for like a couple of minutes or something. And then when on the Earth, when you jump, you just come straight back down.
It's obviously what they bring with them into the lesson of things perhaps they even see on television or just a general understanding. And with Sean with that, you could see that he just hadn't used the right language.
We then moved into this bit where you brought out Astro Bear and the Earth and the Moon.
This is Astro Bear.
This bit here where the boy seems to think that when you jump off the North Pole, you end up on the South Pole.
Astro Bear from the North Pole. If he jumps, where's he going to land? Sean?
In the South Pole.
She's going to do that?
You modelled that situation really well.
It was quite an interesting, because I wouldn't myself have picked up on that misconception instantly. I wouldn't have thought, oh, I bet some children think that happens. And I don't want to make the child think, oh, I've said something completely wrong. I wanted to give him a chance to perhaps change his mind over what he'd said. So when I sort of moved the bear to the bottom, he could see that that was quite an incorrect statement for him to make, and he saw that himself, and I think he changed his mind and said, oh, no, that doesn't happen. Which, for him to see that is better than me telling him.
Absolutely.
Sometimes.
Yes, yes. And I think we can sort of see that illustrated here with Tom, who talks about Astro Bear being pushed away from the moon.
Pulls him upwards, it pushes him upwards. Because
Pushes him
when
upwards?
he's jumping on the Earth, he just comes straight back down because the Earth's core. But when on the moon, when he jumps, he goes higher and stays there for longer, and then he comes back down.
But I thought the way you dealt with that was really well, the pair and share. Is that a tactic you use a lot?
It tends to be, yeah. I think discussion is a vital tool for the children to make sure that they become aware of their own misconceptions rather than being just told it's wrong. Turn to your partner very quickly now and say, and discuss with each other, how is it that this is different? You said it's different, my statement here said it's different. There is something different about gravity here and here. I wonder if it's something that you can tell me before I tell you.
When you're in Earth, you'd only jump up for a short amount of time, then come straight back down. Yeah.
I don't want to be standing at the front and say, no, that's not right, this is the right answer. They will learn more from each other sometimes than they might do from me.
But if there's not much gravity on the Earth, we would be able to jump far higher, wouldn't we?
It was about this time of the lesson as well that they were coming up with terms which they probably are aware of, they've come across, such as core, such as magnetic field, sort of magnetic forces, and trying to link them in. Now, that's quite a difficult thing to deal with when they're coming up with scientific words, but they're being used incorrectly.
Megan?
Is it like magnets? Because when you put a South Pole and a North Pole together with magnets, they both like connect. And if you put weight and gravity together, they'll work together to pull you down.
It is difficult because you then don't want to go down the route of explaining those words in such detail. So it's almost, as I did before, is to stop and say, OK, we've heard these words, we know what they're involved in, but in this particular case, they're not quite right. Our bear, Astro Bear, has our bear from here to here been on a crash diet? Has he stopped eating junk food? Has he then decided to lose a lot of weight?
You were getting to the crux of it here in describing the difference between weight and mass. And we've got this problem of scientific words having a different use in everyday language and having to overcome that barrier.
His mass doesn't change, but it gets confusing because we all talk about weight and we say what do things weigh. And you weigh yourself and you weigh fruit and you weigh things when you go shopping and things. But it gets a bit confusing because his mass is 66 kilograms. That doesn't change, the amount of stuff he's got in him.
Gauging how well, as a class, they're progressing.
Yeah.
I don't know, have you ever sort of considered using traffic light cards, true-false questions, where they hold up either a red card or a green card, to give you an idea as to how well the whole class is understanding and following the lesson? Or maybe the use of whiteboards?
I use whiteboards quite a lot, I think more often than I use the traffic light cards. I think with it being sort of the beginning of the year with the class, I haven't thrown in too many strategies all at once, and it would be something I'd build in there. What do you think that is going to measure? Ben, what do you think it's going to measure?
Newton.
Newtons, so it's measuring what?
Well, weight.
Weight, excellent. It's going to be the measure the weight of an object, and we're measuring the weight as a force.
Right, now at that point they are using the scientific language correctly and precisely as well, which is just what we're looking for. We moved from there into the practical session there, and a lot of good work went on with these pupils.
30.
What is the unit of measure for weight?
My head Newton 225.
In terms of accuracy, how were you gauging whether they were using those scales accurately or not?
I think it was coming from the amount of questions that I got asked of I can't read my scale or I can't. And once I felt that I'd had one too many questions almost, I thought, right, we'll stop. Because I keep hearing, mine's broke, or this isn't working, or I can't read it very well. All those sorts of things that I'm hearing. This force meter measures up to 5 newtons. If I pick up a particularly heavy object, such as this, I might find that the scale, that the balance, the spring, is pulled all the way down to the bottom. Perhaps looking back now, might think, well, I would do that first time round and say, right, we must all measure this for its mass, and we'll all get the same reading, then we're all very clear on how to use it. I just wanted them to perhaps explore a little bit and for some of them to work it out. When that wasn't happening for the majority of the class, right, we stopped and we all then looked at, OK, let's do it 3 or 4 times, different force meters, let's check with somebody else. I can pick a force meter that's somewhere in between, but just because perhaps your spring gets pulled all the way down to the end, doesn't mean it's broken.
So really you're saying there that the accuracy bit was being able to select the right force meter to use to get a reading on the scale that was readable.
Right, so you need something between 5 and 100.
That one.
What's that?
50.
Try it. Go and get your globe. Let's try it.
I particularly like this bit here with the teaching assistant. And she brought in a digital camera and used it with the group there. Could you just run through what she was trying to do there?
Perhaps sometimes those children who will have worked more in a group discussion level and may have written less down can refer back to those. They'll take a copy of those pictures, they'll put them in the book and linking back to, do you remember when we did this in the lesson?
And what was its mass?
400.
Right, so we're going to remember that, and we're going to stick a photo in our book and write that by the side of it.
Can we do mine now?
Yeah, come on then.
Throughout the lesson, we could see that she's engaged with this one group, and some of the questions that we can hear are sort of good open-ended questions. They're not just closed questions.
The Earth makes its own gravity, so what does the Moon do?
Make its own, but it can't make as much as the Earth because it's only small.
Brilliant.
How closely do you liaise with her? How much planning is she involved in?
Sort of speak to her schemes of work before the beginning of a half term or beginning of the topic. We'll then have a brief chat basically about both of our ideas, and at the end of each lesson we will have, sometimes only a briefest of chats where we sort of discuss how we both felt it went, and I can then put that into my planning and pass that on, or we can just say, right, where do we go next? And it's very organised and it works well. I've got up on the board 3 sentence starters really.
At the end of the lesson in the plenary, you asked the group what I thought were some quite challenging questions to sort of fill into their books. Gravity is, weight is, mass is. Was that what you were hoping for or planned?
It was what I'd planned, and I perhaps, looking back now, it was quite open-ended, and I wanted that because I wanted them to make sure they showed me their understanding. I made sure, I said about the keywords, and they were vitally important. Then looking back, and then perhaps changing that round slightly, I wanted it more linked to what we'd done in the lesson. I wanted it for them to use more of a concrete, well, this is what happened when we used AstroBear, or this is what happened when we did this and when we used the force meters.
I mean, she's put out some good things. I mean, she says that the bigger the planet, the stronger the gravitational pull is. It's great. And then if you're on Jupiter, you probably wouldn't be able to lift your feet. But then she does support it a bit by saying on Pluto you might float away.
Yeah, think of this here. Have we been measuring and all that this afternoon?
And again, it's the preciseness of the language. Weight is how heavy an object is.
Yeah.
And again, we want that term force in there. It's the force acting down due to gravity.
Gravity on the moon is so little compared to the amount the Earth makes.
Gravity seems to be the one that we've got, so I think the majority of the class have got. It's here. When we talk about weight.
Yes, you can weigh it in kilograms, newtons and stones plus ounces. Seems to have gone for the scattergun approach.
Yeah,
now.
we've just got everything. Everything in there and we'll hit the mark.
Yes, yeah. And again, the preciseness here, mass is the stuff we have inside us. I mean, not actually talking about the amount of material that sort of goes to make us up, but...
He's made a start
he's
with
on
it,
the way.
hasn't he? Yeah.
No, he's certainly on the way there.
Mass is the stuff we have inside us. No, I've got it in the first bit. 4.
It's a very difficult concept for them to get hold of, and I think it will need reinforcing. And as you go through, you're just beginning it now. It's the first time they would have met these terms. But when we go into Key Stage 3, it'll be revisited.
Yeah.
Again, to Key Stage 4, it'll be revisited. And I've even seen A-level lessons where they come back to this point time and time again.
Measure, shall I put it on the board?
I mean, there's another one here. Weight is a force that changes as you go to another planet. Wonderful. I mean, that's it just needs a bit of expanding about the force that pulls you towards the centre of the planet, but very nearly there.
To have the two in the same sentence shows, we're getting there with that one. Yeah,
but
definitely.
then spoils it. Mass is how much something weighs.
Yep. It's that misuse of the word.
Yes. So it's this everyday language again. We keep coming back to that, and they'll find it difficult to get out of that. Yeah. But it's persistence.
Perhaps think about it in terms of telling me, using the keywords, what you have learnt today about weight.
And they're going to keep coming across this. As they go into the next steps, they'll come across the terms work and power used differently. Yeah. And this is probably one of the first times they encounter that. And as we've seen in the lesson, cause 1 or 2 problems. If you were to do that lesson again, would you do it in the same way?
I'd definitely, I'd use the models, that AstroBear would be there, and I'd be the force meters, and definitely useful. I think the idea of us as a whole class perhaps doing a task of measuring something would combat the problem that we had, so that would be something I'd change. I would probably try the traffic lights as an on-the-spot assessment. Mm-hmm. And the plenary, again, perhaps my wording of gravity is mass is weight is, perhaps the challenge again was literary rather than science understanding, and I would look again at that.
Well, thank you very much.